A Brief History of Time, Review. A Brief History of Time, written by renowned physicist Stephen Hawking, is a groundbreaking work that aims to explain complex concepts in cosmology and physics to a general audience. While it doesn't delve into the intricate mathematical details, it offers a captivating journey through the universe, exploring fundamental questions about its origins, structure, and future. The book begins by introducing the concept of space and time, emphasizing their interconnectedness as a four-dimensional fabric known as space-time. Hawking then delves into the history of our understanding of the universe, starting with the ancient Greeks and their geocentric model. He then discusses the revolutionary work of Copernicus and Galileo, who challenged this model with the heliocentric view. The book then explores the development of modern physics, focusing on the theories of Isaac Newton and Albert Einstein. Hawking explains Newton's laws of motion and gravity, which were successful in explaining the motion of planets and other celestial bodies. However, he also highlights the limitations of Newtonian physics in explaining phenomena at very high speeds or strong gravitational fields. Hawking then delves into Einstein's theory of relativity, both special and general. He explains how special relativity revolutionized our understanding of space, time, and gravity, introducing concepts like time dilation and length contraction. General relativity, on the other hand, describes gravity as a curvature of spacetime caused by massive objects. The book then moves on to discuss the Big Bang Theory, which explains the origin of the universe. Hawking describes the evidence supporting the Big Bang, including the cosmic microwave background radiation and the expansion of the universe. He also discusses the concept of the singularity, a point of infinite density and temperature where the universe is believed to have originated. Hawking then explores the nature of black holes, which are regions of spacetime where gravity is so strong that nothing, not even light, can escape. He explains how black holes form from the collapse of massive stars and discusses their properties, including their event horizon and singularity. The book also delves into the nature of light and its wave-particle duality, explaining how light can behave both as a wave and as a particle. He then discusses quantum mechanics, a theory that describes the behavior of matter and energy at the atomic and subatomic levels. Hawking concludes the book by exploring the possibility of a unified theory of everything, which would combine all the fundamental forces of nature into a single framework. He discusses the challenges of such a theory and the potential implications for our understanding of the universe. Throughout the book, Hawking uses clear and concise language, avoiding overly technical jargon and incorporating helpful analogies to make complex concepts accessible to a wider audience. He also emphasizes the importance of scientific inquiry and the ongoing search for knowledge about the universe. A Brief History of Time is not just a scientific treatise but also a philosophical reflection on the nature of reality. Hawking raises profound questions about the existence of time, the possibility of time travel, and the ultimate fate of the universe. He encourages readers to think critically about the world around them and to embrace the wonder and mystery of the cosmos. In conclusion, A Brief History of Time is a captivating and thought-provoking journey through the universe, offering a glimpse into the vastness of space and the complexities of physics. It is a book that can inspire anyone to explore the wonders of the cosmos and to appreciate the beauty and elegance of the laws of nature. Here are the key scientific breakthroughs discussed in A Brief History of Time that have shaped our understanding of the universe. Copernican revolution. This shift from a geocentric, Earth-centered, to a heliocentric, Sun-centered, model of the solar system was a pivotal moment. It challenged the prevailing worldview and paved the way for further astronomical discoveries. Newtonian physics. Isaac Newton's laws of motion and gravity revolutionized our understanding of how objects move and interact. They provided a framework for explaining the motion of planets, tides, and other celestial phenomena. Einstein's relativity. Albert Einstein's theories of special and general relativity fundamentally changed our understanding of space, time, and gravity. Special relativity showed that the speed of light is constant for all observers and that time and space are relative. General relativity described gravity as a curvature of spacetime caused by massive objects. The Big Bang Theory. This theory, supported by observational evidence like the cosmic microwave background radiation and the expansion of the universe, explains the origin of the universe from a hot, dense state. Quantum mechanics. This theory describes the behavior of matter and energy at the atomic and subatomic levels. It introduced concepts like wave-particle duality and quantum entanglement, which have profound implications for our understanding of the universe. Black holes, these objects, predicted by Einstein's general relativity, are regions of spacetime where gravity is so strong that nothing, not even light, can escape. Their discovery and study have provided insights into the nature of gravity and the evolution of stars. These breakthroughs, discussed in detail in A Brief History of Time, have fundamentally changed our understanding of the universe, from its origin and evolution to the nature of space, time, and gravity. A Brief History of Time delves into the philosophical implications of our current understanding of the cosmos, though it does so subtly and without explicitly stating its own conclusions. Here are some key areas where Hawking explores these implications. The nature of time. Hawking discusses the concept of time as a dimension within the fabric of space-time. This challenges the traditional view of time as an absolute and unchanging entity. He explores the possibility of time travel, raising questions about free will and determinism. The role of human observation. Hawking touches on the observer effect in quantum mechanics, where the act of observation can influence the outcome of an event. This raises questions about the nature of reality and whether it exists independently of our perception. The anthropic principle, while not explicitly named, Hawking discusses the idea that the universe appears fine-tuned for the existence of life. This raises questions about whether the universe is a product of chance or design, and whether our existence is just a coincidence or part of a grand plan. The search for a unified theory. Hawking's exploration of the quest for a unified theory of everything touches on the philosophical question of whether a complete understanding of the universe is possible. He also raises questions about the limits of human knowledge and the possibility of encountering concepts beyond our current comprehension. The meaning of existence. While not explicitly stated, the book implicitly raises questions about the meaning of human existence in a vast and potentially infinite universe. The sheer scale of the cosmos and our own insignificance in comparison can lead to existential questions about our purpose and place in the universe. Hawking doesn't offer definitive answers to these philosophical questions, but he encourages readers to consider them and to engage in their own critical thinking about the implications of our scientific understanding of the universe. He emphasizes the importance of asking questions, exploring different possibilities, and embracing the ongoing search for knowledge. Hawking's discussion of time travel in A Brief History of Time directly intersects with the philosophical debate about free will and determinism. While he doesn't offer definitive answers, he raises thought-provoking questions that challenge our understanding of these concepts. 1. Time travel and determinism. The paradox of changing the past. Hawking acknowledges the grandfather paradox. If you travel back in time and kill your grandfather, you wouldn't exist to travel back in time in the first place. This paradox suggests that time travel might be impossible, or at least limited in its scope. This limitation could be seen as supporting a deterministic view of the universe, where events are predetermined and unchangeable. Multiple histories. Hawking proposes the many worlds interpretation of quantum mechanics, where every possible outcome of a quantum event exists in a separate universe. This could imply that time travel might be possible within these parallel universes, but it wouldn't affect our own timeline. This interpretation suggests a less deterministic view, where multiple possibilities exist simultaneously. 2. Free will and time travel. The ability to change the past. If time travel were possible, it would raise questions about the nature of free will. If we could go back in time and change events, it would suggest that our choices in the present are not truly free, as they could be influenced by future actions. The implications of predetermined events. If time travel is impossible, it could imply that the past is fixed and unchangeable, suggesting a deterministic universe where our choices are predetermined. This would challenge the notion of free will. Hawking's stance. While he doesn't explicitly take a side in the free will versus determinism debate, his discussion of time travel highlights the complexities and contradictions that arise when considering these concepts in the context of our understanding of the universe. He encourages readers to think critically about these issues and to consider the implications of different possibilities. In conclusion, Hawking's exploration of time travel serves as a thought experiment that forces us to confront the philosophical implications of our understanding of time. It prompts us to consider whether our actions are truly free or predetermined, and whether the past is fixed or open to change. Hawking's discussion of time travel in A Brief History of Time presents a fascinating challenge to the notion of a deterministic universe, where every event is predetermined and unchangeable. Here's how. 1. The paradox of changing the past. Determinism implies impossibility. If the universe is truly deterministic, then every event is fixed, including our actions and choices. The grandfather paradox, where you travel back in time and kill your grandfather, highlights this contradiction. If you could change the past, it would imply that the past isn't fixed, contradicting the deterministic view. Hawking's ambiguity. Hawking doesn't explicitly state whether time travel is possible or not. He acknowledges the paradox but also suggests potential solutions, like the many worlds interpretation of quantum mechanics. This ambiguity leaves room for the possibility of time travel, which would challenge determinism. 2. The many worlds interpretation and free will. Multiple histories. The many worlds interpretation suggests that every quantum event creates a split in the universe, leading to multiple parallel realities. This implies that time travel might be possible within these parallel universes, but it wouldn't affect our own timeline. Free will in a multiverse. If time travel is possible in these parallel universes, it could suggest that our choices in our own universe are not predetermined, as they could be influenced by future actions in other universes. This would support a less deterministic view, where free will exists within a multiverse. 3. The limits of determinism. Quantum uncertainty. Hawking acknowledges the role of quantum uncertainty in the universe, where events at the subatomic level are inherently probabilistic. This inherent randomness challenges the deterministic view, as it suggests that not all events are predetermined. The observer effect. Hawking also mentions the observer effect in quantum mechanics, where the act of observation can influence the outcome of an event. This suggests that our actions, as observers, can have a real impact on the universe, challenging the idea of a predetermined and fixed reality. Conclusion. While Hawking doesn't explicitly reject determinism, his exploration of time travel raises crucial questions about its compatibility with a deterministic universe. The paradoxes and possibilities he presents suggest that our understanding of time and the universe is still evolving, and that the deterministic view might be too simplistic to fully encompass the complexities of reality. His work encourages us to consider alternative perspectives and to remain open to the possibility of free will and a less deterministic universe. Hawking's exploration of a unified theory of everything in A Brief History of Time highlights the limits of human knowledge in several ways. The complexity of the universe. He acknowledges that the universe is incredibly complex, governed by multiple fundamental forces operating at different scales. Unifying these forces into a single framework is a monumental task, requiring a level of understanding that may be beyond our current capabilities. The limits of our senses. Our senses are limited in their ability to perceive the universe. We can only directly observe a small portion of the electromagnetic spectrum, and our understanding of the very small, quantum realm, and the very large, cosmology, relies on complex theoretical models and indirect observations. This raises questions about whether we can ever fully grasp the true nature of reality. The role of mathematical tools. While mathematics is a powerful tool for describing the universe, it is ultimately a human construct. Hawking suggests that our current mathematical tools may not be sufficient to fully describe a unified theory, and we may need to develop new mathematical frameworks to understand the universe at its deepest level. The potential for unknowable concepts. Hawking speculates that a unified theory might reveal concepts and phenomena that are currently beyond our comprehension. He suggests that we may encounter unknowable truths that defy our current understanding and require a fundamental shift in our way of thinking. The importance of humility. Hawking's exploration of a unified theory emphasizes the importance of humility in the face of the vastness and complexity of the universe. He acknowledges that our knowledge is constantly evolving and that there are still many mysteries to be unraveled. This humility encourages us to remain open to new ideas and to acknowledge the limitations of our current understanding. In conclusion, Hawking's exploration of a unified theory of everything serves as a reminder of the vastness of the universe and the limitations of human knowledge. It encourages us to embrace the unknown, to continue exploring the mysteries of the cosmos, and to remain humble in the face of the vastness of what we don't yet understand.